Thank you, Craig. So I just want to give you guys a viewpoint of our MLOps journey. Just taking you through an initiative that is very close to my heart, and an initiative that actually will allow us to realize a lot of business value. So I think just to put it into perspective, whether you're at the outset of your MLOps or at the outset of your MLOps journey, or maturing or hardening your pipelines, I'm hoping that this talk provides a practical illustration and provides you with some level of enlightenment. So, to no avail, I do want to start with our mission and overall impact. As a team, we focus on two key areas. So, number one is understanding how we can empower the business to adopt AI and ML to unlock untapped business potential. And number two, how do we drive innovation? And by driving innovation, we'd ultimately want to almost focus and create this data-centric mindset. Furthermore, I think just to unpack some of the areas in which we've actually delivered value. So we've been very strategic in the way that we've actually implemented our solutions. We've delivered value in areas that mattered most. So number one being our growth area, so which is basically our sales and leads optimization. And the other is retention, so our persistency analytics. And furthermore, client experience. So that tackles our underwriting and empowering our advisors. I think whilst we've been able to deliver value, there's always been the struggle in a number of our workflows. And we've been able to build models at scale quickly, but we've never been able to deploy models very quickly. And as a result, I think the true test of your ML capability is whether or not you can actually integrate within business processes quite efficiently. And this speaks to the change catalyst. So number one, there's been a growing demand from the business to ultimately, for us as a team, to build out a lot of predictive analytics solutions. And as a result, how do we go about integrating much more quicker? In addition to that, we've effectively got an organizational shift to move to cloud. So putting this all together, we needed to reevaluate how do we actually empower the business to ultimately scale so that we don't become a bottleneck. And this is essentially where the conversation of MLOps really comes into play. So at the outset, we felt that MLOps basically has, I would say, three preconceived or predefined benefits. These are three interlinking benefits. So number one being scalability. Are we able, or we feel that MLOps is able to templatize the way that we work such that we are able to effectively move from experimentation to production at scale? And secondly, breaking the silos, allowing us to deliver far more impactful data-driven solutions. From a collaboration perspective, we operate in a hub and spoke operating model, and as a result, we'd want to be able to cross-pollinate ideologies with various teams such that we can empower them to empower other teams going forward, and further inculcating that data-centric mindset. And lastly is the future fitting of skills. I think this is quite imperative and quite close to my heart as well. I feel far too often we as leaders really focus on the semantics and the outputs, not really appreciate the amount of effort that actually goes into delivering one of these outputs. And as a result, it's fairly key to upskill your workforce, upskill your talent such that you almost bridge the skills gap and you allow them to accelerate the build phase as well as the deployment phase. In terms of building out an MLOps platform, so there's a few things I just want to touch on. Number one is understanding and dissecting the previous or current landscape. So that's very key. It's very easy to build out this perfect utopian world and build out this ecosystem that nobody can actually use. So it's important to take into consideration the skill level of your team, the organizational landscape, such that you actually build something that is future fit and something that people can actually utilize. The second thing is collaboration. I think collaboration is no longer a strategy. I think it's a necessity. And ideally, you'd want things to happen organically within the organization, but sometimes it's always good to have a fresh perspective on things. And I do want to actually just touch on the collaboration that we have with Melio AI, who have been nothing but amazing. And lastly is actually the technical build of the platform. So how do we templatize things in such a way that we can build once, reuse many times, such that we can scale things accordingly? So in order to understand our previous landscape, I've got a few introspection components that I want to touch on. Number one is the data. So Within my team, there's a lot of solutions that we create that have repetitive tasks from a data wrangling perspective. So multiple scripts whereby ultimately you'd want to have sort of one unified ML feature store that can streamline the data wrangling process so that data scientists can actually focus on much more impactful tasks like value quantification. The second is we come in from an on-premise way of working, so our data is centralized on an on-premise lake, and as a result, we are unable to actually talk to or communicate to our AutoML landscape or predictive modeling engine. And from an ML modeling perspective, there's two things that I just want to dissect. Number one, given the fact that we rely heavily on an AutoML capability, it almost limits that level of autonomy as a data scientist. There's a lot of research that's going into Gen AI as well as traditional machine learning that you'd want to ultimately encourage your data scientists to actually perform. And then from an experimentation standpoint is compute freedom, right? So as it stands, or in our previous way of working, we were really capacitated by our localized machines. So very, very restrictive in the way that we actually prototype. And from a CI/CD perspective, this is quite key, and I just want to touch on firstly the version control. So whilst we've been able to almost codify a lot of our projects and have some sort of level of version control, ideally we'd want a Git workflow or some sort of version control system that allows us to have that necessary auditing in place. Secondly, whilst we've got our AutoML platform that gives us the capability of deploying, we almost lack the ability to scale that a little bit more just based on licensing requirements. And furthermore, given the fact that our data source actually doesn't talk to our ML modeling capability, we almost can't perform the necessary continuous retrain that we want to. And lastly, I just want to touch on streamline pipeline health. So this is quite key. Far too often we're able to build out a model, but we ultimately don't want to end up in the conundrum whereby the business is able to pick up a defect in our model or a degradation in our model far quicker than we are. So that is something that's quite imperative and key that we'd want to encompass within our CI/CD process. And lastly is the operational readiness. So twofold. Number one, organizational. So at Sanlam, we've basically made a unified approach to go with AWS, which actually gives us a good motivation, or gave us a good motivation to ultimately streamline the way that we construct our platform and ecosystem. And lastly, from a team perspective, my team is quite heavy from a data science point of view and with limited engineering skills. And I'm aware of that the engineering skills are really the backbone of the team to almost have an ecosystem that allows you to iterate and improve upon that. So I think just to put it from a practical standpoint, I just want to showcase just the workflow, how things actually looked previously in my team. So from a data wrangling perspective, we've got our on-premise data lake that I mentioned with a lot of tables within various schemas. There's source table amalgamations that we would do native to SQL. We would create this input table that would almost serve as your training input or your batch scoring input, and an output table that almost serves as your output for the various models that you're building. We've got a lightweight orchestration tool that allows us to orchestrate as and when we'd want to actually schedule these runs. And furthermore, from an extra normalization perspective, data scientists within my team would basically go to their localized machines to perform extra normalization within Jupyter Lab or RStudio on their local machine. So very much constrained in terms of the amount of RAM and capabilities that you have available. After that normalization has taken place, there's almost a flat file export that happens, and that flat file export basically serves as an input into our predictive modeling engine, and we are able to effectively build out our model. But like I mentioned, I think the true test of your ML capability is really in how you deploy at scale. So the two types of deployments that we actually have is API and the jar file deployment. So jar file deployment is just really a serialized way of taking that model and embedding it directly into a business process. And whilst we've got the capability of deploying via API, like I mentioned previously, we've got a restriction just in terms of our licensing agreement, and things become very costly if you want to expose more slots and deploy more models. But I'll just take you through the workflow from an API perspective as well as the jar file binding. From an API deployment, we have our trained model. We essentially rely on a non-native orchestration tool that sits outside of our platform, So creating that level of technical dependency outside of the skills of my team in order to facilitate the input invocation and the output right back into that table for upstream consumption by business systems. The second deployment is the jar file deployment. It does sound attractive, so it has its pros and cons. One is that you can actually front load a lot of the effort or the engineering effort towards business development teams. But the downside of that is that it's almost a reactive approach when your model degrades. So you don't have the capability to do an automatic retrain. You almost have to wait for a release cycle in order to change that jar file. How does a new way of working actually look from a reference architecture perspective? So I think taking into consideration all of the gaps within the team and the introspections that we spoke about, number one is to have something that allows us to facilitate the version control auditing as well as to almost orchestrate our various flows. So we've got GitHub that allows us to house our source code as well as to segregate our build and deployment workflows. Two is Amazon SageMaker, which is really the powerhouse for our model build. So as I mentioned, team members were capacitated by their localized machines. They now will have the freedom of almost experimenting and ultimately checking in their source code into a repository. So ensuring that we have freedom to compute, and number two, for that level of auditability. And then if we wanted to formalize a workstream workload, we'd ultimately want to trigger a build workflow, which will have a templatized way of data pre-processing, model training, model evaluation, as well as the registering of that model. That model sits within a model registry, and we allow for the QA and approval process either by a senior data scientist or a team lead within my space to almost have the necessary sanitization checks before we actually deploy into production. So once approved, this model will basically feed into our two-stage accounts in which the ML engineer will almost take it through all the way to production. This will be served in two ways, real-time as well as batch. And furthermore, I think just to unpack on the deficiency that we had is almost to have that model monitoring capability, to have that proactive approach to understand when a model degrades, can we retrain, can we actually publish our endpoints much more quicker. And in addition to that, the ability to write these outputs into our on-premise data lake for upstream consumption. And lastly, whilst maybe not really important, but we do have the capability, is also almost to have an automatic retrain. So should you define any specific metrics or triggers, we would essentially be able to almost retrain as and when these criteria have been met. So I think putting the new workflow into place, we thought, we pondered quite hard as to how we could actually get this over the line. And that's really where we reached out to Melio AI. And as I mentioned, they've been nothing but amazing. And I just want to touch on three key components that really stood out for me. Number one is the domain expertise. Team is really well versed in MLOps, DevOps. It's not just a team that's vibe coding their way throughout. They actually understand the AWS ecosystem quite well. The second is just the level of professionalism. I think there's been a great deal of transparency throughout the whole journey. The engagement from the outset to post-deployment has been really phenomenal. And lastly, I think is a big one for me is just most of the culture. It's just that collaborative mindset. So they've really treated us like partners as opposed to just clients, and really tried to enrich and impart as much knowledge as they could, whilst still keeping their eye on what the end goal was. And it would probably be a big disservice for me to not have the Melio team present with me, and to no avail, I hand over to Harry to take us through the technical build.
Cool. Awesome. Cool. Thanks for those very kind words, Vedanth. Great. Cool. Hi everyone. So over the next two slides, I'll be providing you with an overview of the core principles and considerations that we adhere to when we implemented the MLOps platform. I'll also share some of the challenges as well as the not so obvious gotchas that we encountered during this project. So the requirements that were provided in the beginning of the project was quite clear. So we needed to build a comprehensive, secure and scalable MLOps platform based on Amazon SageMaker. We needed to design the platform to accelerate the machine learning lifecycle from experimentation all the way to production deployment. while adhering to the stringent organizational governance as well as security standards. So based on this, we designed and implemented the MLOps platform based on 4 core principles: ensuring a robust enterprise-grade environment for the data scientists to do machine learning development and operations. So the first core principle is security and governance. So security is paramount. It's integrated at every single layer of the platform. The key components that we implemented include multi-account isolation, so the separation between the build, validate, and deploy accounts, private VPC networking to ensure that the platform as well as the deployed model is only accessible from within Sanlam's internal network. We provided identity access control for both users as well as services to ensure that we follow the least privileged access patterns. Auditable logs as well as traces via CloudWatch as well as CloudTrail ensure that we align with the organizational governance. So with these controls in place, the real challenge is actually balancing the strict governance with fast experimentation. So how do you actually go about that? In most enterprises, you'll see that there's a concept of environmental separation. You have a development environment, you have test environments, and you have production environments. And these environments are further separated via AWS accounts. In our case, our platform uses 3 production-grade accounts: build, validate, and deploy. So even build, which sounds like a development environment, actually handles real data. So it still must meet production controls. So in order to keep experimentation safe for the data scientist, we created sandboxes within the build account using strict IAM boundaries. So we ensure that the feature flags as well as network segmentation is in place so that the data scientists can move fast without compromising governance. The second core principles that we followed is modularity. So we designed the platform as a collection of interoperable, exchangeable components that can be switched out or switched off when not required. And this is achieved by using infrastructure as code with both Terraform and CloudFormation. We support various types of machine learning and data science use cases. So from your batch scoring triggered on a monthly schedule, all the way to real-time inference endpoints running on a serverless model. The MLOps platform also allows the data scientists to use the tool that they're most familiar with. So that's why we support both SageMaker Studio as well as SageMaker Canvas. If the data scientists are more comfortable using their own preferred IDE, such as VS Code, we allow them to actually build their own SageMaker pipelines via the Python SDK. We also support bringing in the data scientists' own custom models that they have trained using third-party AutoML platforms. So you might wonder why we use both Terraform and CloudFormation. And the simple answer here is that we picked the best fit technology per the infrastructure layer, as well as considering the competency of the team. So the Sanlam team was strongest at Terraform. So we used it for most of the shared services as well as the cross-account infrastructure. We still chose CloudFormation, where it fits the SageMaker's native workflow, such as using service catalogers cleanly. The third core principle is automate everything. So automation is leveraged extensively to increase efficiency, reduce manual error, as well as accelerate time to market for these data science projects. Our GitOps-driven approach uses separate, standardized repositories, ensuring a clear separation of concerns between model building and model deployment. SageMaker Project's graphical user interface, very user-friendly, allows the MLOps engineers to easily and quickly create data science projects with all the bells and whistles automatically created in the background. And these include bootstrapping GitHub repositories, linking them up to GitHub runners, the Codeball runners, as well as creating and provisioning CloudFormation templates for either batch scoring or real-time use cases. And within each SageMaker project, the project leads are also able to get visibility into the progress as well as the status of the use cases, deciding whether or not to actually let the team know that they are behind or ahead of schedule. Last but not least, the observability core principle allows us to implement comprehensive monitoring to provide deep visibility into platform health, model performance, as well as operational costs. So over here, we take a centralized monitoring approach where we combine both the infrastructure performance as well as the model performance into a single view. Cost management is done through extensive research of the Cost Explorer dashboard as well as the report and setting budget alerts. And because access is quite tightly controlled within these 3 accounts, we needed ways to expose the right signals for debugging without giving every team member access to everything. So the access to validate and deploy accounts is quite restricted, which makes the break, feedback, and fix debugging cycle quite tricky. So we solved this by using various runbook scripts that allows us to pull the right logs and as well as metrics on demand. We also ship integration checks with every single project. So these include data quality tests, prediction accuracy tests, as well as endpoint health monitoring. So issues can be surfaced early. Great. So now that you know about the 4 core principles that we followed when we're building out the MLOps platform, let's talk about why this platform works for Sanlam and highlight some of the components that the team use extensively. So from the fragmented tooling landscape to a unified platform built on top of SageMaker, the experimentation environment, which the data scientists use extensively based on SageMaker Studio, serves as a central IDE for data scientists, providing managed Jupyter Lab environments, Git integration, and access to shared resources such as S3 and EFS. We've also implemented lifecycle configurations to automate the setup of the environments with the required packages and tools, so that when the environment spins up, data scientist is ready to start their exploratory data analysis. The SageMaker Model Registry is a central repository for versioning, managing, and governing all of the trained models. And it allows us to track model lineage, model metadata, as well as model approval statuses. Next, CI/CD and inference setup, directly a result of our extensive automation, allows us to reduce cognitive load for the team. With the team adopting the GitOps approach, powered by GitHub as well as AWS Code Build, the build, test, and deployment process is automated, further reducing the operator overhead as well as cost. Our platform supports multiple inference options, so this includes real-time, batch, as well as serverless, which allows the team to choose the most appropriate and the most cost-effective method for their use case. The platform is built to evolve. So with the modular infrastructure, it enables only the components relevant to each data science to be provisioned. And with these reusable components, it provides the Sanlam team the freedom to structure their data science initiatives in a mix and match style. And this results in initiatives being onboarded and ready for the data scientists in hours rather than days. So now I'll hand over back to Vedanth to talk more about how the business is empowered by using the MLOps platform.
Thanks, Harry.
Thanks.
So Harry mentions a key word about evolve or evolution. So I want to take you through a business case that we've developed. It basically is angled towards improving our retention or our overall persistency and our value of in-force profits. So how can we come up with an early detection model or an early lapse model to empower our retention unit consultants to effectively have a much more scientific way of prioritizing which clients should they actually perform their retention exercises on. So I'll take you through how the landscape would have looked. So still bearing in mind that we do have our on-premise data lake. So we'd effectively have our input data model, which will be scheduled to run on a monthly basis within our on-premise data lake, basically uploading that into our predictive modeling engine to perform the necessary batch scoring. That scored output is basically read back into a localized file directory. There's additional normalization that actually happens, and that final file is placed on a file share, which then gets consumed by business integration teams into upstream consumption for our retention unit consultants to prioritize the various cases. In the new way of working, or our current way of working, we still remain on premise, still have our batch scoring data set. However, this batch scoring data set is persisted or replicated into our S3 bucket, into AWS, and effectively we've got a train model which is sitting within our SageMaker model registry, and we have a batch transform job which facilitates the necessary invocation, and the post-processing step which does the necessary normalization required by the business, which then is output into an S3 directory in which the business integration team now connects directly into that S3 bucket as opposed to the localized file share. and the retention unit consultants can effectively perform the necessary prioritization. With that being said, I think a few call-outs. So, as I mentioned previously, we had a lot of repetitive scripts, especially within the sales and retention space. What we've done, we've basically created this normalized or unified feature store to allow our data scientists to spend less time on data wrangling and more time on building and actually quantifying the value of our solutions. So what we've noticed or what we've observed was a reduction in wrangling time for about 50%. The second call out that I've mentioned is now that it ultimately allows business integration teams to change their way of working. So no longer looking at localized file shares, actually connecting directly to the cloud. And one additional call out just to mention is that whilst this is a solution for a particular business unit, it's actually a methodology that can be democratized and be shared as a marketplace. So it can be reusable in the way that we actually templatize the way that we're working. And I think just to summarize just some of the key learnings from our journey. Number one is to really understand your landscape. Like I mentioned, I can't stress this enough. If you spend a lot of time just building out this perfect utopian world, you'll end up with a lot of technical debt and platform that nobody will actually want to utilize. Number two is really choosing the right partner or collaborating effectively, either organically or external with a fresh pair of eyes. There's no one size that fits all. And I don't think any platform is perfect, and I don't think any platform should be perfect. It should always be an iterative effort for progression. And lastly, a cliche statement, start small and be patient and really focus on building the skills for your team, and ultimately also bearing in mind the business upliftment that you want to achieve from building out these ecosystems. The future state, as I mentioned, we've deployed a lot of models using jar file roots. We want to ultimately migrate that and test our vigor within our real-time deployment space, and essentially scale that across not only the life and savings cluster, but to other parts of the organization. And GenAI, I think we've delivered or created some POC solutions, but I think that there's massive opportunity for us to scale and scale out our generative AI operations. The third is really to almost democratize this in such a way that we are able to almost have our solutions as a marketplace or rendered in a marketplace. I think far too often we build the same models for various business units, so it makes it easier for us to ultimately empower other business units to consume various models like churn models, lapse models, sales models, and so forth. And lastly is the creation of a self-service portal, so an internal developer portal, almost abstracting the infrastructure away from your machine learning engineers or data scientists and almost making it a UI-driven workflow. And before we wrap up, I'd like to leave you with a lighter note, a quote that I think captures the spirit of what we've discussed. I feel that there's always two ways of spreading light. Number one is to be the candle, and number two is the mirror that reflects it. Craig, over to you.
Thank you.